VSEPR theory is used to predict the shape of molecules. At higher level, hybridization can be used too. VS refers to the valence shell, the outermost energy level. EP refers to electron pairs. R refers to repulsion. You start with the Lewis structure, count the number of charge centers. These are electron pairs in bonds or non-bonding pairs. Note, a double or triple bond counts as one charge center. These are then positioned so they are as far apart as possible. The shape of the molecule is determined by the angle between the bonded atoms. Non-bonding repel more, so they push the bonded atoms closer together.
This molecule is carbon dioxide. You can see here is a carbon atom and two oxygen atoms. And here we have two double bonded bonds. And there are two number of charge centers. And we have two double bonds. The shape of the molecule is linear since the angle is 108.
It has an sp hybridization. Right, so this is ethene. It has a Lewis structure of two carbon atoms bonded to four hydrogen atoms, each one is bonded to two. When you're looking at a structure of ethene, you look at one carbon atom individually. It has three charge centers because of this. Because if you block this C out, you'll have one charge center here, and one here. The number of bond pairs and non-bond pairs is 3, because there are no non-bonding pairs in the individual one. That is the Lewis structure of ethene, where you can see the double bond between the two carbon atoms and the four white hydrogen atoms. The shape of the molecule is trigonal planar. It has a hybridization of sp2, and the bond angles between the hydrogens is 120. So this is boron fluoride. The fluorides, the three fluorides are bonded to a single boron atom. You can see that the fluorides are in a covalent bonding and they have 8 valency electrons. However, the boron does not follow the octet rule and it only has 6 outermost electrons. The number of charge centers again is 3, as in ethene. The number of bond pairs and non-bond pairs is 3. There is no non-bonding pair except for the ones in fluorine where you can see 3. There is a hybridization of sp2. And there is a 120-degree angle between the fluorides. That is clear here, where you can see that they are like in a triangle, and the shape of the molecule is a trigonal plane.
This is sulfur dioxide. It has a resonance structure because it has two bond pairs with the oxygen and one daily bond with the other oxygen. But there is the localized pi bond between both oxygens. It also has one non-bonding pair, which gives it 3 charge centers. The shape due to its charge centers would be trigonal planar, but because of the non-bonding pair, they are in a V shape. This pushes the angles from 120 to around 117. Sulfur is sp2 hybridized.
This molecule is methane. It has 4 charge centers and it has no lone pairs. The shape of the charge centers is tetrahedral and the shape of the molecule is tetrahedral. The bond angles are 109.5 and the hybridization is sp3.
My molecule is ammonia NH3. It has a number of 4 charge centers and there are 3 bonding pairs and 1 non-bonding pair. The shape of the charge centers is a tetrahedral because of 4 charge centers, and the shape of the molecule without the non-bonding pairs is a trigonal bipyramid. And the bond angles is 107. It is reduced from 109.5 because of the non-bonding pair, and the hybridization of ammonia is sp3.
My molecule is the ammonium ion. It is a positive ion. It has a Lewis structure with 4 charge centers, of which 3 are regular bonding. They're all bonding pairs, but one is a dative bond. It has bond angles of 109.5, and its shape is tetrahedral as well as the shape of the charge centers. Its hybridization it's sp3.
My molecule is water. As you can see, it has 4 charge centers. Here it has 2 bond pairs and two non-bonding pairs. The shape of the charge centers is going to be tetrahedral. However, because it has 2 non-bonding pairs, the shape is going to be V-shaped. The bond angles are going to be 105 degrees. The molecule of water is sp3 hybridized.
My molecule is hydronium. This is the structure. It has 1 oxygen and 3 hydrogens, but one of them is data gradient bonded. So this has 4 charge centers and 3 bonding pairs and 1 non-bonding pair. The shape of the charge centers is tetrahedral. However, the shape of the molecule is trigonal pyramid. Due to the lone pair, the bond angles are not the same as it would be in normal tetrahedral. Instead, they are around 107, and the whole molecule is sp3 hybridized.
This molecule is called a phosphorus pentafluoride, PF5. Here we can see the Lewis structure, and the number of charge centers is 5. The number of non-bonding pairs is 0, and there are 5 bonding pairs in this molecule. The shape of the charge centers is a trigonal bipyramid, and this is the same shape for the molecule because there are no non-bonding pairs. The bond angles of this molecule, there are 2 of them. Here we can see the 90 degrees and the 120. The hybridization of this molecule is DSP3 due to the fact that it doesn't follow the octet rule, so that is why you have the D subshell. My molecule is sulfur tetrafluoride, is SF4. Here's the Lewis structure. Sulfur tetrafluoride has 5 charge centers and 1 non-bonding pair. The shape of the charge centers is going to be a trigonal bipyramid. However, because of the 1 non-bonding pair, the shape is going to be a sawhorse. The bond angles of sulfur tetrafluoride are going to be from 90 to 170 degrees. Sulfur tetrafluoride is DSP3 hybridized.
My molecule is iodine trichloride. The number of charge centers is 5, and the shape of the molecule is a T-shape. And the shape of the centers is trigonal bipyramid. The bond angles are 90, and the hybridization is DSP3.
Here we can see xenon difluoride. It has 5 charge centers, of which 2 are bonding pairs and 3 are non-bonding pairs. Therefore, the shape of the charge centers would be trigonal bipyramid, and the shape of the molecule would be linear, as you can see. Its bond angles would be of 180, and its hybridization would be DSP3.
My molecule is sulfur hexafluoride. It has 6 charge centers, 1, 2, 3, 4, 5, 6, and it has 6 bonding pairs and no non-bonding pairs. The hybridization is D2sp3 because it does not follow the octet rule and has an extended octet. Its shape is octahedral, and the shape of the charge centers is octahedral as well. It has a bond angles of 90 degrees.
My molecule is bromium pentafluoride. Bromium pentafluoride has a total of 6 charge centers, 5 bonding pairs and 1 non-bonding pair. The shape of the charge centers would be octahedral, but because of the non-bonding pair, it has a square pyramid shape, but still it remains with angles of about 90 degrees. Parts of the molecule is a bit less than 90 degrees because of the non-bonding pair, and the molecule is D2sp3 hybridized.
This is my molecule. It's xenon tetrafluoride. As you can see, it's got 1 xenon with 4 single bonded fluorides. It has 6 charge centers with 2 non-bonding pairs and 4 bonded pairs. Its shape of charge centers is octahedral. However, the shape of the molecule is square planar. It has bond angles of 90 degrees. It is D2sp3 hybridized.